please look over those things, like in your notes and stuff like that. Okay? All right. So, let's begin here. Like I said, we're going to be looking at a kind of a different topic today. And those two different topics both deal with inequalities. Okay? And how to kind of solve things with inequalities. And some more like complicated stuff than rather than just, our normal thing here. So let's see. Okay. So, all right, let me see if we can get this unfrozen here. Okay. So, we'll call this notes. Okay. And we are again solving quadratic and absolute value inequalities. Okay, and we'll actually start with the absolute value ones first here. Okay, so let's start with absolute value inequalities. Okay, and how to kind of work with those things. So before we look at what an absolute value inequality is, though, it's helpful to remember what the meaning of the absolute value, or what is the meaning of the absolute value. So, what does absolute value mean? What does it mean? What's the idea behind absolute value? So, yep.
Distance from 0.
Yes. Okay, that is the key understanding of absolute value, right? We all know what absolute value really does, and maybe that's really the most comfortable that we are with absolute value. We just it makes things positive, right? That's like one way we think about it. But really, absolute value is distance, okay, from 0 on the number line. And it's helpful to think about that, distance from 0 on the number line, which now maybe makes a little bit more sense about why absolute value has that property of making things positive, because a distance, right, it doesn't really ever talk about a distance. You don't really think about a distance being negative. Conceptually, a distance should always be positive. So, when we see something like, a basic absolute value like this, right, like absolute value of x, for example, and let's just say, it equals, 3, we'll say. So this is an equation, obviously, because it's got the equal sign there. But one way, the better, more conceptual way to think about this is to think, all right, absolute value of x. That means the distance of that thing from 0, we want it to be 3. Okay, so if you think about your number line, right, what numbers are 3 units away from 0? 3 and negative 3, right? 3 and negative 3, which is why when you solve an equation like that, you both have positive 3 as a solution and x equals negative 3 as a solution as well. Both of those work because they're both, on the number line, 3 units away from 0. Right? So then what happens when we have something like, I guess that's an example maybe. So let's now take the same absolute value, but now let's make it greater than 3 away from 0. Greater than 3 away from 0. Okay. So we still want to use the idea of distance from 0. We still want to use that distance from 0 idea. But now, if we think about our number line here, and I'll actually draw this on the number line just so we can see it better. Okay. Here's 0, right? I'm just going to put 0 in the middle there. I don't have to do that normally, but I'll just do it. Okay. Negative 1, negative 2, negative 3, negative 4. Okay. So to be greater than 3, so we want our value here, we want this thing to be greater than 3 away from 0. So that means to go greater than 3 away in this direction, all right, to go, so like this way, so here's 3 away exactly. If we want to go greater than 3 away, that means we want all the values x greater than 3, right? Because here's 1, 2, 3 away. I want to be greater than 3 away, so I want to be more than 3 away from 0 there. So we'll go, let's say x is greater than 3. Okay. Alternatively, though, I can also go 3 away from 0 in this direction, and I'm at negative 3 now. But if I want to go more than 3 units away from 0, that means I want to go, what other values here are going to be more than 3 units away from 0 in this direction? Yeah, less than negative 3. So like negative 4 will be more than 3 away from 0. Negative 5, 6, 7, 8, 9, 10, and so on and so forth. And so we also want x to be less than the negative 3 there. And so our graph, if we were to graph this, would end up looking like this, right? Open circle at 3 because there's no equal to there, and then greater than 3, so we would, kind of go this direction. Okay. And then for x less than negative 3, open circle at negative 3, and then again shade to the left, and kind of highlight the arrow there. If you'd like to graph like above your number line or below your number line, that's fine too. You can do that as well. I just did it on my line. But if you'd like to put your points above the number line, that's okay too. Below it, whatever you want to do. So x greater than negative 3. There's that. All right, so let's change it up a little bit then, right? Let's look at one more. Let's take a look at absolute value of x is less than or equal to, and let's say 1. So again, I'll draw a number line here to give us kind of an idea. Start with 0. But again, better to think of the absolute value of x not as making things positive, right, but as distance from 0. So again, absolute value, think of it as distance. We want the distance of this thing, we want the distance of x, all our solutions here, the distance of this, to be less than or equal to 1. Less than or equal to 1 away from 0. So from 0, I go 1 away in this direction, right? And so I can, put a dot there. I'm going to go less than, so I want to go this direction, to the left. I'm going to go less than 0 away. But I can also go 1 away in this direction, right? So from 0, I can go 1 away in this direction, but I'm going to go less than that 1 away. So I don't want to go further away, right? Negative 2, that'd be further away. I want to say closer to 0, less than 1 away. So again, solid dot there, and in this way, and so it's these two. And so this one, you can make it a compound inequality. You could say like, negative 1 less than or equal to x less than or equal to 1. Alternatively, you can just make it a compound inequality like an and. X is greater than or equal to negative 1, and x is less than or equal to 1. And this one over here would be an or inequality since they don't overlap. So questions on either of those? Questions on either of those? Those are like the basic ones there. And these kind of relationships will always be true with the given inequalities, okay? So for greater than or equal to's, you're going to end up with an or where, the two inequalities are going to go opposite directions. Okay, one's going to go more than, one's going to go more than 3 away, one's going to go less than the opposite, negative 3 away. And then for the less than or equal to's, you'll always end up with the and compound inequality there. And. So it's going to be between the two extremes there of the negative 1 and the 1. Okay. So those are conceptual ideas there, right? And again, if you need help remembering, and this is not great, but I mean, I guess this was shown to me. I don't know if this will help you or not, but people are like, oh, it's great or than. Okay. And this one here is less than. So it helps you remember which compound inequality you get from either greater than or the less than. Of course, the less than, you could say greater than 2, but that wouldn't be right, so don't do that, right? So it's not how helpful it is, but it's something to help you remember the different kinds of inequalities you get there. But it's better to remember it from the absolute value there, how it's distance from 0. If you want to be greater than a certain number away from 0, you're going to go opposite direction. If you want to be less than a certain number in from 0, then you're going to be between two numbers there. Anyway. All right. Let's try another one here. So let's see. Yeah. Of course, we're not always going to have just x in the absolute value there, right? We can have other stuff like x plus, I don't know, 3 here is less than or equal to, and I don't know, we'll say 4. So now the complicated thing is here, right? We can't just subtract 3 from both sides. Or actually, it would kind of work out this way. We want to be careful about trying to get rid of things like from inside the absolute values there, because we have to take that absolute value. So we want to kind of isolate this absolute value, which it is isolated, right? It's all by itself. And now we want to break this up, okay? So since this is a less than or equal to, that means we're going to be between -4 and +4 there. All right, we want our distance from 0 of this thing, in this case the thing is x plus 3, we want that to be less than or equal to 4 away. So that means we want that x plus 3 to be greater than or equal to -4, and the x plus 3 is less than or equal to 4. Okay. And for a less than, it's going to be an and compound inequality. You'll also notice here, or maybe you didn't notice, but I'll point it out too, that the relationship, the two inequalities. So this absolute value inequality essentially breaks up into two inequalities, right? One of those inequalities is the exact same as the original absolute value one. It just drops the absolute values. The other one is almost the exact same thing, except the sign gets flipped, right? Less than becomes greater than, greater than becomes less than, and then the positive 3 became -3, right? And the same situation happens here, even for the less than too. You can see that we have the x, absolute value of x is less than or equal to 1. That stays the same right there for that one, right? We still have the x is less than or equal to 1. And then the other one here is just flipping around the sign from less than or equal to greater than or equal to, and then from 1 to -1. So that can also help you kind of come up with these easier. So the same idea here, right? We take the absolute value of x plus 3, which is less than or equal to 4. That one stays the same. There it is, just without the absolute values. And then you flip the inequality sign around and make that the opposite of 4, -4. And there's that one. So you have both of them to solve. And so we'll subtract 3 from both sides. You get x is greater than or equal to -7, and x is less than or equal to 1. And again, since it's an and, right, they should be pointing towards each other when we graph it, and in fact they will be. So we can just graph it here real quick too. Okay. So -7 less than or equal to, so it's a solid dot, and then 1, it's a solid dot, and then we'll just shade between. And there's all our solutions. Okay. So let's try one more here. Okay, maybe I'll have you guys try this one actually. Never mind. We'll have you guys try this one. Okay, and then move on to the quadratic equations or quadratic inequalities. All right, let's do 2x plus 3. The absolute value of 2x plus 3. Okay, we'll say is greater than or equal to 7. Absolute value of 2x plus 3 is greater than or equal to 7. Let's go ahead and give that one a try there. Solve it. And graph the solutions. Okay, and I'll do that too here real quick. Try and graph it too. Try and graph it too once you got it solved there. Try and graph it too. So let's see here. Emma, were you able to come up with anything for us?
I got x greater than or equal to 2 or x less than or equal to -5.
Perfect, exactly right. Okay, yes. There it is. Again, this is going to be an OR inequality. We're going to be pointing in two different directions here. Why? Because we want our absolute value, our distance from 0 to be greater than or equal to 7. So that means we're going to go, well, we start out with 7, and then we want to be bigger than 7, right? So we keep that inequality sign, 2x plus 3 greater than or equal to 7, right? So it stays the same, we just drop the absolute values. Or we want this value, this thing, to be a distance of less than or equal to -7, right? We want to go in the opposite direction. So when you solve both of those for x, you end up with x is greater than or equal to 2, or x is less than or equal to -5. So that's why we get the two different directions there going. Okay, again, that's because we have the greater than. Greater than, you'll have two different directions. For less than or less than or equal to's, right, you'll have the and, which means you're going to be between two values, because you want to be less than 4 away. So you only go out so far on the right-hand side, you only go so far on the left-hand side, it's going to be between. Okay, so that's the idea. So you'll have more you'll have practice that here in just a second. Once we finish up going over the quadratic inequalities. But any questions on those? Okay. Any questions on those? Okay. So these, I need to correct myself. These inequalities will not be on Friday's quiz, but they will be on the test coming up, next week sometime. Okay, so just keep that in mind. We'll have like 1 or 2 of these on the test then. Okay. All right. So there's that, and the last thing I want to talk about is just solving quadratic inequalities. Okay, and again, we'll just start out with an example here, and let's see here, I might do just 2 of these, I guess, then maybe. Yeah. Okay, yep. Alright, so 2x squared plus 5x, bless you, is greater than 12. Okay, so no absolute values here, just a quadratic inequality. And I'm going to kind of throw it in here because, deals with factoring and stuff like that too. So we're going to, solve it for 0. So we'll, set it equal to 0. Make sure it equals 0 here. So, solve for 0 basically. First, okay, just like in an equations. Okay, so we'll subtract the 12 over. So it's 2x squared plus 5x minus 12 is greater than 0. And then we will factor. Just like we do when we're solving the equations. Okay, so let's see, 2x and x. So, this is minus 3 and then plus 4 there. 8x minus 3x is 5x, yeah. Okay. So now here's the tricky part, right? The way that we kind of then solve from this point, so we fact it, right? But we don't want to just say, all right, now 2x minus 3 is greater than 0 or x plus 4 is greater than 0. We can't quite say that here. We have some kind of strange things going on, because when you multiply two things and you want them to be greater than 0, both could be, if both are positive, then yes, you'll be guaranteed to be greater than 0. But what other way can you multiply two things together and be greater than 0? If they're both what? Negative as well. Yeah, so we got to be careful there. We can't just break this thing up and say, oh, okay, then 2x minus 3 is greater than 0, x plus 4 is greater than 0. It doesn't quite work out that way, because we can also solve it for when 2x minus 3 is less than 0 and x plus 4 is less than 0. And anyway, so here's what we're going to do. We're going to solve this thing like we would an equation. We're just going to say 2x minus 3 equals 0, x plus 4 equals 0. Okay, and we're going to get our zeros. Okay. And yes, I know it's a greater than, it's not greater than or equal to, so technically these two values, but you'll see here. We're going to use these two numbers to, okay. So we have our two zeros here, 3 halves and negative 4. And so we're going to use these two numbers to kind of break up our number line. Okay, and this I'm going to be really, I don't know what I'm going to say here, but okay, I'm going to make a really, basic number line here with just the exact numbers that we need. We're going to put our two zeros on there. And so these two zeros, they break our number line up into two or three different intervals, right? We know that at 3 halves and at negative 4, we're going to put open circles because we can't equal those values because we don't want to equal 0, right? Those are where we equal 0, and we don't want to equal 0 because we just want greater than 0. And so now it's a matter of just picking which intervals make this inequality true. Okay, so we're just going to kind of guess and check here. So, for example, to test this interval, what's a number that's in this interval right here? Yeah, that's negative 5. So let's just try negative 5 and see what happens. Okay, let's just try negative 5 and see what happens. So if I plug negative 5 back in, and you can plug the negative 5 wherever you want. If you're going to plug the negative 5 in here for both x values and then see if you get greater than 12, then that's fine. You can plug it in for x values here and see if you get something that's greater than 0. But I think the best place to plug that negative 5 in is right in here. So we would have 2 times negative 5 minus 3. And then negative 5 plus 4. Okay, so just plug the negative 5 in for the x in the factored form. And why am I doing that? Because, well, you'll see here. I don't need to really worry about what this value is. I just know I'm going 2 times the negative number, which will be negative. I'm going to then subtract 3, so that's going to be a negative number overall. And then negative 5 plus 4, that's also going to be negative. And what's a negative times a negative? Positive. So does this interval have solutions in it? The answer is yeah. And so it's in fact the entire interval. If one number works, then the entire interval works. So we know they're going to shade in this direction. Now, let's try another interval here. Let's try this interval right here, right? What's a good number to pick in this interval? Yeah, 0. Good. So we'll try 0. Okay, again, we'll plug that 0 in. So it's 2 times 0 minus 3, 0 plus 4. So here it's going to be 0 minus 3, right? 2 times 0 is 0. Minus 3 is a negative number. 0 plus 4 is a positive number. Negative times a positive is negative. So that won't work, right? Because we want it to be greater than 0. We want this thing to be greater than 0. So negative is no good. And so you guys probably will be able to guess here what's going to happen with this interval, but let's just try like 2. Okay, because 2 is in that interval. And so we'll do 2 times 2 minus 3, and then 2 plus 4, like that. And so we get 4 minus 3, which is 1, which is positive, and then 2 plus 4 is 6, positive, so positive times a positive is positive. And so we got this whole interval as well. Okay. So there's our solution set, okay? So we can say, we could write it as an inequality. So, let me see here. So step 4, we break up the number line. Oh, thank you, sir. Okay. Break up the number line using zeros. And step 5, we test our intervals there. Or test intervals, not tested, test intervals. Okay? So, we've got that. And so you can leave your equation, your solutions graph that way. We could use an inequality here and say that, the solutions are x is less than negative 4 or x is greater than 3/2. Okay, so you can use an inequality there. Or you can use interval notation. Negative infinity to negative 4, not including it, and then union 3/2 to infinity. Same kind of idea. Okay. So there's that. Questions on any of that? I'm going to do one more here with you, and then I'll cut you guys loose. Alright, try some problems on your own here. Alright, last one. Let's say again we want to solve x squared plus 2x plus 4, and we want to know when is that greater than 0. So again, we want to solve it for 0. Well, it's already set equal to 0, or set greater than 0 at least, so we don't have to get the, we don't have to get 0 there. And then we want to factor this thing. So, does it factor? Yeah, it does not factor. Womp womp. Okay, so what does that mean? What do we do? Well, we could get zeros for this using the quadratic formula, right? So we can't get zeros by factoring because it doesn't factor nicely, but we could still get zeros potentially by using the quadratic formula. So let's use that. So we get, let's see here, x equals negative b, so negative 2, plus or minus the square root of 2 squared, which is 4, minus 4 times 1 times 4, all over 2 times a there, which is 1. But we can see that what's going to be true about our zeros here? Imaginary. Okay, so we don't have any zeros. But that doesn't mean that we don't have solutions to this inequality, right? So it just means that this inequality never equals 0, which means when we go to break up our number line, When we go to break up our number line, there are no borders, right? There's no boundaries. There's no boundaries here. There's no zeros for us to graph because this thing, when you try and find the zeros, there are no zeros. They're imaginary. So there's no zeros for us to graph on our number line. So our number line is one interval, right? Before, we used our zeros to break up our number line into 3 intervals here. Since there were no zeros, there's only one interval. It's the entire number line. So what would be a good number to pick to try on this number line here? What number should we guess here? Any number you want. 1, okay, 1. Or 0. That'd be a good one too. So you're just going to try 1. We're going to plug 1 in. 1 squared plus 2 times 1 plus 4. Is that greater than 0, right? That's what we want to know. So let's see, we get 1 plus 2 plus 4. It's greater than 0. That means the entire number line works. Okay, the whole thing. Any number you pick, if you plug it in for x there, okay, will be greater than 0. Right. There was no boundary. There's no intervals there. It's just all one interval. The whole number line is right over there. Okay. Compare that then. So what if we change this up slightly? If we said x squared plus 2x plus 4 is less than 0. Right? So all I did was just change that inequality sign. Well, again, there would still be no zeros. Okay, so we can still draw our number line there. And again, we can pick any number we want. I'm going to try just 0 this time. Just because it want to be different. 0 is easier to calculate. We plug in 0, it'll be 0 squared plus 2 times 0 plus 4 is less than 0. So we're left with 4 is less than 0. And when is 4 less than 0? Never. So there are no solutions here because that inequality will never be true. And this one is all real numbers. 4. So those are some other possibilities there, right? Questions on any of that? So again, I fit these two things in today because they're both dealing with inequalities, but you're doing slightly different things here. With the absolute value inequalities, you're trying to determine whether you're going, whether it's going to be, the opposite directions or pointing in towards each other based on the fact whether you have a greater than, that's opposites, right, or the less than, where you're pointing in together, and then graphing those solutions, but it deals with an inequality. Or if you've got the quadratic inequalities, you're just factoring it, solving for the zeros, putting those two down, and just testing your intervals there. That's it. Okay, so that's all I've got for you guys, and I'll get you guys started on your assignment here then, okay? So, we are done.